imagine, not even the best sci-fi movie, the diversity of the planetary system that we have detected. So the reality is way more diverse than anything we had in mind. We have this lava planet, this frozen planet, this super Earth, mini Neptunes. This is the reality of the diversity of the planetary formation.
In the 90s, for the very first time, we demonstrated, using a new technique, that there are planets orbiting other stars. We found a planet orbiting a star called 51 Pegasi. That planet was about the mass of Jupiter, similar to our own planet Jupiter, but had a very short orbit, was essentially very close to the star, and then extremely hot. This is what we call the hot Jupiter. And that was the beginning of a long series of discoveries and what we call right now the exoplanet revolution. My name is Didier Queloz. I'm professor of physics at Cambridge University and ETH Zurich. My main activity is to study planets orbiting other stars, try to understand how they look like, and eventually trying to find out whether there may be some planet with life as well. Science is everywhere in the society, and we should take any opportunity to bring science into life of everybody. When you have people interested by video games, if there is a little bit of a chance that through these video games, through this exercise of the gaming, and then I can sneak in and with a couple of minutes of interaction through the video games, I can maybe suggest some idea which is scientifically relevant, bring a little bit more knowledge into the society. Something which is great when you deal with what's called planetary science is you can essentially expect everything. We have learned in the past 30 years that the diversity of the planet are way more and way larger than the one we experience on the solar system. And assuming that there are so many planets and so many stars in the universe, it's very likely that there exists plenty of planets like they created for the game. Jareil 6 is the first planet you meet in Onkai star rail, covered by harsh hurricanes and snow. The planet has been covered by snow for hundreds of years. Snow almost killed the civilization there. And people on the planet somehow managed to maintain only one city with the help of a special energy. When you talk about a planet that is frosted, and we know that in the past of the Earth, we may have encountered this very special situation where the Earth was like a snowball. When you're dealing with a frozen planet, there's a lot of possibilities. First, you have to realize that the gas, if you cool it down enough, like carbon dioxide, will become icy and frost. So it's easy to consider a planet that will be seen as a gaseous planet. I mean, cooling down enough and looking very, very icy. Now, it depends also of the amount of water you have on the planet and whether you have a big oceans and whether you want to create a kind of an ice crust from this water. Or you don't have water at all, but you build up this kind of icy structure for all the tiny gas that is transformed in a solid because it's very cold. So what matters here is the temperature. You have to cool down the temperature, so you should not get too close to the star. If you're too close to the star, it doesn't work. But you also have to be careful about the structure of the atmosphere of the planet. I take an example like Venus. Venus is full of carbon dioxide, and that warms the planet. It's a greenhouse effect. Well, if you remove this, and you can bring gas that is cooling the planet as well, and that happened on Earth, and the Earth had way more carbon dioxide in the past because of the rise of life and a lot of production of oxygen. That was one of the big effects called the Great Oxygenation Event. The whole atmosphere of Earth has been transformed, and at that time the temperature equilibrium was dramatically changed, and the Earth became what we call a snowball. So it was exactly the kind of icy planet you will encounter in the game, and that was a result of a dramatic change of the nature of the atmosphere of that planet. So you see there's so much possibilities you can play with. It depends really on the chemistry of the planet, on the structure of the planet, and then of course of the amount of energy which is radiating on the planet by the star. So what has happened in the last 30 years is we have been exposed to a diversity of planetary systems that no one would have imagined. When you have a rocky planet, depending where the planet is sitting on its orbit, you have a different scenario on the surface of the planet. Take the Earth, bring it closer to the Sun, you're going to end up with one face of the Earth extremely hot, so hot that you would melt the continent. So you end up with what we call a lava planet. Now, another case is you can imagine you take the Earth and you make it much bigger than the Earth. Not one Earth mass, maybe 5-10 times the mass of the Earth. And you have a lot of carbon as well. So you have all this carbon on the planet, and then you have this higher mass. Higher mass means pressure. The more mass you have, more pressure you have on the planet. When you combine the carbon and the pressure, you create diamond. It's exactly how you create diamond on Earth. So this kind of a very massive planet, you could imagine they should be full of diamond. Astronomy is a wonderful topic for research because we are studying a specific element, which is the universe. And for us, astrophysicists, universe is our lab. And that's a wonderful lab because that's a lab that has so much possibilities, way more than any lab you can imagine on Earth. For example, you can see through the time, depending how far you look at, you look back in time. You can look at objects which are just impossible to reproduce, like a black hole, which is an infinite point where everything is attracted. We can look at objects that are extremely hot, at a temperature you will never think about it. You can look at energy event which is unique, like a supernova, again and again and again. So you are looking at what's called the extreme boundary of the physics, the coolest, the biggest, the smallest, anything you can get into the universe. And that's wonderful. Possibly one of the biggest questions of the humankind is there any life outside the solar system? Fermi paradox was half a joke when Enrico Fermi said, well, if there is plenty of life in the universe, so why don't we see it? And actually the question is very profound in its meaning. It implied that life has to develop and to be able to travel between stars and galaxies. Maybe we are not able to see it. So if there is no life traveling between galaxies, it means that maybe there is a possibility that when life develops the capability to do it, it just stops. Just looking at the thermonuclear weapon we have on Earth right now, we have not the capability to travel between stars, but are we going to survive until we are reaching that stage? And that is what is behind really the Fermi paradox. Life may be common in terms of being started on other stars, but the development of life leading to a species that would be able to lift off from its planet may be extremely rare. And think about our stories. Without these big asteroids falling on Earth, maybe this planet would be still populated by dinosaurs. And whether the dinosaur could have been evolving and go to the moon is not sure. Maybe it's very rare. Maybe we are the only life entity with the awareness of the knowledge of the universe in this galaxy. So it's also something to think about it and maybe to cherish our situation, our extreme situation, our responsibility on that matter. So I think this Fermi paradox is interesting in terms of philosophical sense because it asks the question of the meaning of our civilizations and the destiny of our civilizations. At the same time, it demonstrates how beautiful is our destiny to be able to ask the question already. So whether we will one day get the answer, I don't know. I tend to be optimistic and to be a believer to the kindness of humankind, but we still have to face serious challenging as a global entity because we have only one place to live. It's this planet, nowhere else. And we should really, as a global populations, better learn how to address it together, to use it wisely if one day we want to have any hope of our species to travel to other stars.
Come with me, take the journey.